Hey guys, I think we can start. Let me just pull up slides real quick here. Game. So today ano lang tayo? Excuse me. Uh, we'll have a final discussion on DB scan, which we discussed previously. No? And then we'll have a synthesis of maybe the various machine learning topics we've discussed with respect to agent-based systems. So basically wrapping up the semester already. So it's great that we were able to tackle as many topics in place. But right now, let's try to tie everything that we've learned for machine learning, for the advanced topics, going back, let's tie that back into agent-based systems. So recall that we mentioned and discussed DB-scan previously. Sorry, that we I showed you guys how it worked, worked you guys through a demonstration site. And what this essentially is about is DB-scan is an algorithm that's used to cluster data that's usually very noisy. And because it's very noise tolerant, it's able to cut the signal from the noise, remove all of these outliers, and it's able to find really effective clusters as opposed to k-means clustering. So here's how it works. You typically don't require the number of clusters for k-means for DB-scan to run on. What the difference here is, unlike k-means, sa k-means kasi you have to specify the number of k clusters that you want to chuck your data into buckets. And this is an exercise in its own right. You have to be able to optimize how many k buckets you'll be chucking your data into. The DB-scan, the trade-off is you don't need to find these numbers of buckets. In exchange, you have to tune two other parameters, your epsilon and your min points value. So epsilon is essentially the inverse base density the algorithm considers in grouping points. So let's unpack this. Density, going back to physics, is your sige, can anyone tell me what the general equation for density is? Kahit sa chat na lang. Okay, that's correct, no? So you're working with volume here. You're trying to identify how much mass there is for volume. And volume is a function of base times height times width, diba? So this is for 3D space because we live in a 3D world. But if you're working with a two-dimensional data set, you're essentially trying to find mass over area. So area is the two-dimensional version of volume, the three-dimensional. And if you go into four-dimensional, it's a hypercube na. Going down to one dimension, that's a line. So what we're essentially trying to do here is to find the base density, the inverse base density when it comes to grouping points. So what does this mean? So if we have, let's say, the density, so to speak, the area of the area of a 2D space, you're trying to find how many points are inside that. So we're trying to divide mass or points over the number of surface area, so to speak, that we're working with here. So going back to the previous example that we tried to cluster coffee shop locations, our area would literally be surface land area, land surface area. And this is why we're working with two-dimensional data sets, because it's easy to visualize clustering exercises for. Go beyond that, 5, 6, 7, kung ma-visualize nyo yun, you guys are nuts. That's amazing. But at most, we can visualize 3 space. 4 space is something we can experience, but not really visualize. That'll be cool though. But essentially, we're trying to find the inverse base density based on the epsilon value. And then the minimum points value is something different. It's essentially, well, the number of minimum points you need to declare a cluster. So we use these two parameters to tune how much data there will be per cluster, and what density of points do we look into, do we consider to define a cluster as well. So it's number of points and density. It's these two parameters. So density can be in 2 space, XY, 3 space, XYZ, 4 space, XYZ, A, 5 space, XYZ, A, B. So as many as you need it to be. Yeah, so benefits of DBSCAN is we're able to discover potentially multiple clusters without having to manually identify or iterate through the number of K clusters that we normally would have done in K-means. Okay, so clusters of any shape, it's tolerant of any outliers, noisy data. We're able to group data according to curves, loops, concentric circles, blobs, even planes like the one here listed below. And it definitely will be great at ignoring any outliers. So noisy data like these things can be chucked out for something not very useful. So what do I mean here? So we have here these points, these two teal colored points. Using DBSCAN, tapon na yan. Here we have these 2 points. So given this blue cluster here, if we look at its average, the centroid would likely be somewhere here, where my cursor is at. But if we disregard these 2 points and adjust instead here, mas representative yung centroid niya of where the points are rather than somewhere floating in emptiness, no, na medyo weighted. So this is what DBSCAN is really good for. It builds clusters that are more representative of how your data performs rather than how it's located. Sige. Let's move on to a demonstration para mas recall that in clustering 1, we clustered coffee shops as follows, no? Geospatial locations of coffee shops. And we were able to get what looks like a rough cut of north, south, east, west Metro Manila, given these colors, no? But if we start clustering using DBSCAN, we might end up with more representative and distinctive clusters that might be more telling of something useful, no? Like identifying business centers where you want to put up a coffee shop, identifying competitors or potential areas kung saan wala pang negosyo, saan wala pang kalaban, you could put up a coffee shop there, identifying potential population centers. These are things we can all look into. No? So I have here this notebook, which is essentially an extension of the previous one. Here are a list of GPS pairs detailing all of the centroids, centers, so to speak, of the polygons that we have in Metro Manila. So cities within Metro Manila. So Makati, Pasig, Marikina, Quezon City, etc. And then here I have a scraper. We could run this, but it might take a while to run this. No? So I have Código here instead na lang. Loading up the coffee shop's dataset. Loading this up here. So the nice thing about pandas, no, and if you guys decide to pursue further machine learning courses, you will be able to identify that you can chain functions like this. Instead of building your traditional code base na paisa-isa yung call, pwedeng one-liner na lang lahat yan. And that's a very efficient way of building things in a functional programming perspective. When I say functional, it's basically like math. No? You're doing f of x, of g, of h, etc. And this is kind of how it would work. We get name, the name column within my data set. Why is my computer dying? So I'm going to be head. This is what my data set looks like, the first 5 values. Now we have name, lat, long, check-ins, and address. So I get the name column. I do a value count. So this is like a group by. I group my data set by name and count them per instance. I get the first 20. And then I plot it out using this function. So ito yung lumalabas. So we know that we have Starbucks, UCC Vienna, UCC Cafe Terrace, Coffee Bean, Park Cafe, Cafe UK, Chokis, Cafe France, Chocolat, and moving down into the list. So straight up plotting them out here. Sorry guys, medyo na-pause na ako. Hindi ko nang bakit. Teacher homework. Here we have the same data set plotted out. No? And sure, potentially, we see some clusters that we saw previously. No? But here are maybe outliers that we can actually ignore. So let's see how we can play with that. Okay. So dropping this in here, set our values that we will cluster with, and we will cluster with our lat long values. We will ignore the k-means bit. Let's set something like over here. Something's not working correct. There we go. Nag-i-kaos na PC ko. Wait lang. Popping these things out. Filtering out points greater than less than -1. What does this do? -1 yung naging category of points that are outliers. So we don't want to plot out the outliers here. So this is essentially something like a database or an SQL select statement. Select all fields from DBScan cluster where DBScan cluster is greater than -1. Something like that. And this is what we have. Give it time to load. And again, we have multiple clusters in place with a lot of the outliers cut off. And we see that it's more unique now compared to this clustering that essentially just cut Metro Manila into basically 4 sectors. What we have here now are more granular clusters. We have Makati, we have BGC, we even have Poblacion here. We have the Magallanes, the Magallanes area. We have what looks like Green Hills. We have greater granularity with the kind of analysis that we're doing here. Now we have Eastwood here. We have Katipunan. We have West Triangle. We have Trinoma area. Previously, isang bucket lang yung mga lumalabas na clusters dito. So we have that level of capability now with DBScan because we're clustering based on density rather than space, rather than straight up spatial distance. And this is what the advantage of DBScan is. Now, just wanted to show you guys the difference between k-means and DBScan. That it's more nuanced. There are certain things you have to be concerned with, like tuning your epsilon value here and your min samples bit, which I won't really go too deep into. But I want you guys to take this whole idea of, sorry, not this one, this whole idea of clustering unsupervised learning as a way to represent your agent-based systems world. So how does this tie back into our whole AI analysis or our whole AI lesson? So clustering is a way for, well, agents to make sense out of unknown data and find patterns in data. So if you want to have let's say an agent-based system that would identify the optimal coffee shop locations to build, yung potential search space niya would be all of the points within Metro Manila. And the problem would be how to optimize the location of where to put up a coffee shop. So what we could do, given these clusters, we could find the centroids of these clusters and then move to identify as an optimization problem or as a search problem which areas would have the greatest distance from other clusters. So saan yung pinaka-bakante? Saan yung pinakamalayo sa population sa ibang coffee shops? And this is essentially a search problem and an optimization problem. So that would likely be somewhere here, which is what looks like very urban, maybe socioeconomic class C, D, Manila, parts of Mandaluyong, San Juan. And this is, if the data is correct, there are no coffee shops here. And this is very interesting. So you could put up a coffee shop there. These are highly populated centers, and an agent-based system that would track and identify means to find optimization problems like this. No, this is essentially an optimization problem. It would be similar to how you would find the shortest path in traversing Ateneo. In this case, you just be finding the most optimal location to put up a coffee shop, and your organization of data is via unsupervised learning rather than a graph. This is one way that you can integrate these concepts into the whole PEAS agent-based system model that we have in place. Similarly, you could do the same with regression or supervised other supervised learning models like an SVM, a support vector machine. There are multiple ways to process these, as well as with natural language processing. No? Recall that we have agents that can process and understand text to be able to navigate their world. So just think about these things. I think Doc Dre mentioned that this would be a quick lesson today, and I guess that's really the point. No, he'd be yung upload niya na lesson would be a greater synthesis, tying in everything. My communication to you guys would largely be just how to connect machine learning into the overview of what we know AI to be. So recall that AI is our capability and understanding of how intelligence works, and potentially how we can exhibit intelligence in machines, in computers. No? And this is one way we're solving that problem. How do we organize data? As solving problems is one part of intelligence. Representing the problem, making sense of data, is, I think, the first step before solving a problem. Parang prob set lang yan sa math class or sa physics class ninyo. If you have a question or a problem, first few statements, dinedefine mo pa lang yung terms. And then that's when you begin the hypothesis and you begin solving for the problem. So you have your given, your requirements, your equation, your solution, your answer. And this is essentially the process by which we solve problems in the real world, and similarly using AI. So I hope this was very useful for you guys. I hope you guys learned something. Let me know if you guys have any questions or comments regarding this whole brief crash course into machine learning. No? I'll stop my screen share, and I think we can end this short session here. No? Thanks guys for the semester. We'll see each other in the next few weeks pa. But I think this is formally the end of the machine learning section of the course. No? So thanks. I hope it was valuable. As always, let me know if you have any questions. I'll be happy to answer them. Anything AI or ML related. Machine learning, not Mobile Legends. I have stopped playing that game. Wag niyo na akong i-google pabalik doon. So, yeah, thanks guys. Have a great day. Go grab some lunch if you guys haven't.